Hello there, welcome to the A-Level Maths Applied June 2023 paper. Here we're looking at question 5. So it's a bit of a long one. Tizam is playing a game. She uses a ball, a cup and a spinner. The random variable x represents the number the spinner lands on when it's spun. The probability distribution of x is given by the following game. So the first thing she does is spin the spinner. To play the game, the spinner is spun to obtain a value of x. So you spin the spinner and you get 20, 50, 80 or 100. And then Tizam then stands x centimeters from the cup and tries to throw the ball into the cup. Okay, so if you get 50 centimeters, you've got to stand 50 centimeters back and then throw the ball into the cup. The event S represents the event that Tizam successfully throws the ball into the cup. To model this game, Tizam assumes that the probability of S, which is scoring in the cup, given that you've moved back 20, 50, 80 or 100 centimeters, is equal to k over x. That's k over how many centimeters you went back. So the more centimeters you went back, the lower this probability is. The smaller amount of distance you moved back, overall the higher amount of the probability this is. The probability of scoring and getting one of these outcomes here should be the same whatever value of x is obtained from the spinner. Tizam uses the model, so using Tizam's model, show that c equals 8 over 5b and find the probability distribution of x. So let's just give myself a bit more space for this question now. So what we're going to do first is we're going to apply this first statement here, but we're not going to use little x, we're going to use all of the 4 different options that we've got. So the probability of scoring, given that you are 20 meters away from the cup, is equal to k over 20. The probability of scoring, given that you are 50 centimeters away from the cup, is x over 50. The probability of scoring, given that you're standing 80 centimeters away from the cup, is k over 80. And the probability of scoring, given that you are 100 centimeters away from the cup, is k over 100. Probability of S given that x equals 100 is a bit of a complicated way of writing it, but it's basically the probability of scoring if you're standing 100 centimeters away. Okay, now let's apply statement 2, which says that the probability of scoring and being 20 centimeters away from the cup is should be the same. So this is going to be, and I think the two events will be independent because you do one and then you do another. So it's going to be k over 20 times a. So that's the probability of the first event. Probability of the first event times probability of the second event. So probability of scoring when you're 20 centimeters away and spinning the spinner to get 20. So the next one is the probability of S and spinning on the spinner that you're 50 centimeters away. So that is k over 50 times b. Probability that S and x is equal to 80. So that's k over 80 times c. And then the probability of scoring and spinning on the spinner 100 is going to be k over 100 times d. And what statement 2 says is that should be the probability of each of those 4 things I've just worked out should be the same whatever value of x is obtained from the spinner. So that means that this probability and this probability and this probability and this probability are all the same. So to show that c equals 8 over 5b, I'm going to set k over 50 times b equal to k over 80 times c. So let's cancel out the k's on both sides, times 80 to the other side. In fact, I'm going to divide by 10. So 8b equals 5c. So therefore, 8 over 5b equals c. Excellent. So that's part A complete. Now we've got to find the probability distribution of x, which is basically to say calculate A, B, C, and D. So what I'm going to do is I'm going to do virtually the same thing as I did in part A and get A and D also to be in terms of B, and then I know that all of these probabilities will add up to 1 and solve the equation that way. So now I'm going to set the top one and the second one equal to each other. So k over 20 a equals k over 50 b. Cross multiply 5a equals 2b. So then a equals 2 over 5b. So I'm getting everything in terms of b. So now I'm going to do the second formula, second expression, and the fourth expression. So k over 50b equals k over 100d. Cross multiply, in fact, the 50s cancel out, so it'll be 2b equals d. Excellent. So now I've got something that I can replace a with, something I can replace c with, something I can replace d with, knowing that the sum of all of these probabilities should be 1. So let's start with a, which is 2 over 5b, add b itself, add c, which is 8 over 5b, add d, which is 2b. And that should equal 1. So add together all of those terms on the left-hand side. So 2 over 5 on the calculator. Add 1, add 8 over 5, add 2. We get 5b equals 1. So therefore b will equal 0.2. So in my probability distribution, b is now 0.2. Let's now work out a. So a is going to be 2/5 times that, which is 0.2 times 0.4, which is 0.08. C is 1.6 times 0.2, which is 0.32. And D is twice 0.2, so that's 0.4. And a final check just to add all of those together to make 1. Yes, excellent. All of those add together to make 1. So that's the final answer for part B. The answer is this table of probabilities here. Okay, moving on to part C now. So Nav tries a large number of times to throw the ball into the cup from a distance of 100 centimetres. He successfully gets the ball into the cup 30% of the time. State, giving a reason why Tizam's model of the game is not suitable to describe Nav playing the game for all values of x. Okay, so what Nav has now discovered, or by an experiment, is that the probability of scoring, given that you're 100 centimetres away, is 0.3. So this k over 100 is now equal to 0.3. So therefore, when we multiply the 100 to the side, we've worked out that k is now 30. The question says, states giving a reason why Tizam's model of the game is not suitable to describe Nav playing the game for all values of x. So what I'm going to do now is have a look back through all of my probabilities. And in fact, if you now look at the top one, probability of x is equal to 20, probability of scoring when you're 20 centimetres away, would now be, using Nav's model, 30 over 20, which is impossible. So it wouldn't make sense for Nav to assume that k is 30 for all values of x. So there we are, that's the answer for question 8 with a total of 5, so question 5 with a total of 8 marks. Let's now move on to question 6.